Hello, everyone. Welcome to the next installment of the Academy Software Foundation's Careers in Film and Technology webinar series. We have a really exciting program for you today. This one is on VFX careers color scientist. The color scientist is someone who's very, very important to the film industry and is one of the jobs that I love hearing about. So I am particularly excited to get the opportunity to hear the speakers talk today and learn a lot more about this career. So let's go ahead and talk a little bit about where we are in the webinar series. So if this is the first time you joined us, this is a series of presentations. So there are 6 of them in total. We are on the 4th one, the color scientist one, and we have 2 more coming up soon. They run every 2 weeks, so definitely join us in 2 weeks for the next one, which will be on VFX careers pipeline developer. Also another exciting topic that I think you'll really have a lot of fun with. So today's presenters are Carol Payne from Netflix and Michael Dolan from Epic Games. We'll also be joined during the Q&A by Karen Ruggles, who will be joining as a professor to talk about her views on this topic. But in the meantime, let's go ahead and get on with this series and let Carol and Michael speak. But before we get to that, I want to make sure that everyone knows that we will be taking questions through the Q&A box that you can see at the bottom of your Zoom screen. So please go ahead and use that button at any time during the presentation. Type in all of your questions that you come to mind while you're watching them. And I'll be looking at those questions throughout the presentations and using them during the Q&A at the very end. So without further ado, I would like to welcome Carol to the stage. So let me introduce,
hi, everybody.
Carol, sorry. So let me introduce Carol a little bit, tell you a little bit about her. So Carol Payne started her career in visual effects, working for almost 6 years at Industrial Light and Magic, a Lucasfilm company, most prominently as color and imaging engineer. It was there she found her passion in how we capture, create, digitally manipulate, and display imagery to make content shine. Now at ILM, Carol worked on over 30 films, including The Irishman, Star Wars: The Last Jedi, and Avengers: Infinity Wars. In May 2019, Carol joined Netflix as imaging specialist on the creative technology team, focused on standards of the future and how we can best utilize imaging technology to preserve creative intent. Carol is a virtual working group chair for the Academy Color Encoding System, ACES. I never actually have to say it. As well as a technical steering committee member of Open Color IO and a chair of the Academy Software Foundation Diversity and Inclusion Working Group. She and I co-chair. Active in SMPTE and ACM SIGGRAPH, she's also a founding member of Women in Visual Effects. So welcome, Carol.
Thank you very much. I'm happy to be here. Let me share my screen so that we can get going here. All right. So I get to have a very colorful slide deck, which is a rarity for me. So I'm very excited about this slide theme. Just want you guys to all appreciate that. All right, so yeah, color journey is what I'm titling this presentation, and we're going to talk about 4-ish different things with a lot of things shoved in the middle. So I'm going to try not to talk too fast, but sorry if I do in advance. Please ask questions in the Q&A if anything isn't clear. Do my best to explain acronyms and all of that stuff because there is a lot of them. Thanks for the awesome introduction, Rachel, but I also totally prefer to have this slide about me is basically everybody's a human underneath all of their crazy bios, and I still am weird and fun, and I run mostly on caffeine. I'm addicted to plants, and as a color scientist, everybody seems to want to ask me what my favorite color is. So I kind of preempting that here, and it's green, which is not surprising because I love plants. And I also have an inordinate love for GIFs of all forms in many places, sometimes when they're not appropriate. So hopefully you guys like them too, because I think they're great. But really, actually, Rachel gave a good introduction. Oops, sorry. Computer is lagging a little bit. There we go. I did study film and digital media in school. I'm from New Mexico originally, minored in computer science before working at ILM in a few different paths. I started out as a technical assistant, which render wrangling, writing little scripts, monitoring the backups, doing all of these things, learning everything I could about what was going on in all the different areas of ILM, because I honestly didn't know what I wanted to do so much. What I thought I wanted to do ended up not being what I wanted to do, which I think is pretty common for a lot of people. Eventually ended up as a color scientist, learned all that I know about color on the job. So not technically trained in it in any way. And now I'm at Netflix, like Rachel said, I'm on the creative technologies team, and we work a lot on R&D for the future of how we create our content. Yeah, and then as far as open source goes, I'm going to talk a lot about ACES today, Academy Color Encoding System, which I work extensively on, and Michael is going to talk a lot more about OpenColor.io in his talk, but both open source projects that are the color science and visual effects and animation industry wouldn't be able to do the work we do without them. Beyond that, how did I actually get here? Do I have anything that like I could say was like enabled me to sort of get where I want to be? And I figured I'd get the, little bits of wisdom out of the way before I get into the crazy color science topics instead of bringing it back around at the end. And I narrowed it down to 4, and they seem really cheesy when you put them in, text like this. But I wanted to talk about a few things that I think, regardless of what you want to do in your life and your passion or all of those things, all of these 4 things, they translate. They're not unique to the film industry. They're not unique to the tech industry. They're just things that will help you in your career and figuring out your path and making what you want to happen. And the first is pretty obvious. It's never stop learning. It's really, it's so cheesy, but this industry changes all the time. It's only like 3-ish years ago that I'd never worked on anything related to, for example, virtual production in my life, and have had to have crash courses in that. And it's a really big part of everybody in the film industry has had to have a crash course in changing the way that we make content on a lot of our productions. And that's pretty insane. So it happens a lot. It happens all the time. The second one is one I say a lot to people I get the opportunity to talk with and mentor, and it's you're your biggest advocate, but also your biggest enemy. And what I mean by that is everybody has their own motivation. Individuals, your boss has their own motivation, your company as an entity has their motivation and goals, and you have your motivation and goals, and you're the only one that knows what those are, what you want, and what's going to make you happy. And so you have to advocate for that. I see a lot of, just that take what comes to you, earn your keep. You have to take a little bit of crap to get somewhere. And obviously being a team player is really, really important. And sometimes that means work that you don't love 100%. But it's not an excuse to let somebody walk all over you, to let a company or anybody you're working for, any project you're doing, walk all over you or not further your goals. So speak up for yourself. Don't let yourself stand in your way. Don't be afraid to say that you don't know. I admire people so much, and it's something I work on constantly because it's really hard to admit you don't know something, especially in front of people that you admire and that you want to work with, and you want to trust you. But really, in my opinion, a great way to gain people's actual trust is to say, I don't know, and to then follow that up with, but I can figure it out. Let me go and do some research. Let me double check my answer. I'm not quite sure about this. and then follow up. I'd so much prefer that than making up a half answer or not saying anything or pretending like you know. And the fourth one is if you've taken any kind of, a lot of this comes out of computer science classes and things like that, so it might not be super new, but be lazy. We're really fortunate in this day and age to have access to tons of information in a way that like previous generations didn't really, and amazing work that's come before us in our industry and other industries. And there's no point in redoing things and reinventing the wheel, and use what's come before you. Do your research, Google things, figure it out, look to see if there's solutions before you're doing things, and learn from stuff that other people have tried, so that you spend your time doing things that matter, that are critical, that are going to be worth your time. And that's not, it's like funny, it's lazy people, they say be lazy, but it's really not lazy, it's economical and it's smart. So those are my things. That's my bits of wisdom. And now we're going to move on and talk a little bit about color. But like, what even is color science actually? Because it sounds like dark magic of a type that you are somewhere in a lab coat looking at a prism of RGB light and with a magnifying glass, kind of like trying to figure out what's happening. And even like, I did this, I Googled color science and then looked for the definition on Wikipedia. And it's scary. It's not wrong, but color science is a really broad field. It includes a ton of different disciplines and stuff, all the way from physics and optics, so lots of engineering, all the way to a lot of things in your brain, like the medical field around how we see and how that connects to our brain. And it also involves the other end of the spectrum, like colors for printing things, for printing billboards and dyeing fabrics and all of that stuff. And it's just really scary, and it's a lot, and it makes me want to run away and hide in a corner. So for the film and entertainment industry, we're going to simplify. We're mostly, for color science in our industry, we're talking about digital images to a large extent, things created by a computer or captured on a digital sensor. And talking about how we display that, and how we make that all work together and look correct to our eyes when we're looking at a computer screen or at a phone or in a cinema. But it's still not a small problem. It's a big problem. And this is just a slide with a ton of different stills from lots of different digital camera captures that are all unique camera sensors. There's lots of great cameras out there, and they all do things slightly differently based on their engineering and the way that those engineers have decided to maximize those cameras and their capabilities. But we also have the displays on the other side. There's tons of different displays out there. I mentioned 3 just a second ago, but they more and more every day. So how do you tackle this problem of image consistency when a director or a director of photography is really depending on you to make their image look like they expect it to look all the time? And it's a challenging problem. So a little bit around it is that, from the camera side, cameras have really been capable of capturing high dynamic range, high fidelity images that pretty closely resemble what our human eye sees for quite a bit. Even film was a really dynamic medium, and digital sensors have really risen to the task. And so we can capture it. We can capture this stuff. We can also now store it. And we've developed ways of storing these captured images to maintain their integrity. That technology has evolved a lot over the years, moving from an 8-bit JPEG, 10-bit log film scans, to now we can store 32 bits of linear floating point data in an image file, in an EXR file, for example. And that's like 14 stops of dynamic range, like pretty much what any camera can capture in a single image. And we can capture colors that nearly cover the entire range of human vision. So any color that your eyes can see, and not just a subset. So we can capture it and we can store it for the most part. The real issue for a long time has been display limitations of, just display technology has been limited for a long time, all the way, like you think about, your first sort of displays, your CRTs, your like all that projector kind of stuff of they're limited in both the amount of colors they can display and the brightness that they can emit. So monitor technology for a long time, display technology was sort of stuck in a same pattern of what we call SDR, standard dynamic range. Your standard computer monitor, your standard old flat screen TV. But in the last 10 years, that's changed too. And now with the introduction of HDR, high dynamic range. And that's not the high dynamic range that you think about when you see like a photograph that's HDR, where the photographer has shot a bunch of different images and combined them to one for that really high contrast, high saturated look. It's not the same as that because you're still viewing that on a standard display. What we're talking about is displays that are capable of showing in one go a single image that was captured from those high fidelity cameras on a display at a higher brightness and higher contrast ratio. And those displays are becoming more and more common. If you have an iPhone, that is an HDR display. And so the challenges of figuring out capabilities of all these different displays and marrying that with all their different camera inputs. Plus, when we start to talk about all the different departments that have to view and create imagery in a film or game or animation production pipeline, it gets crazy. It's like the spider web of all these different things that you have to track. And it's pretty nuts. And all these different departments have different needs and different styles and different ways of viewing images. And the way we track this and the system that we've invented to be able to do this is a system called color management. And there's a couple different ways to do it, but it's really, color management is taking the work out of the process, creating a workflow that's reliable and standardized. Because if you think about it, like, there's so many different, this is another way to visualize how many different parts of the film production pipeline, for example, need to view an image. So you're talking about DIT and you're starting there, and it's, are you guys seeing what, there we go. Your DIT cart, and you're creating grades on set. And those grades also need to be viewed in editorial and on review, and visual effects artists need to be able to accurately represent the dailies. And so they're having to, sorry, I see in the chat, DIT, digital imaging technician. They're focused on set, on creating grades on set for the visual effects house to use later and for the colorist to use later, so that everything kind of matches up. And yeah, so all of these, so now we're like at 5 places. And then if you go a step further and add in all of these different things that, there's a cycle, there's repeats, there's changes. And at the end, the colorist has to figure out how to make this work on lots of different displays. And they have to figure out how to archive it accurately so that if things want to change at a later date, they don't have to go start from scratch. They have some place to start from that isn't going to take them exactly the same amount of time that it did the first time. It should be a little quicker and a little bit more future proof. So that's a lot of information. Where does open source fit into this? For me and for the film industry, it goes back to that being lazy mantra. We could, at our individual companies, do all of this on our own. We could each do it our own ways at our different companies. And we did for a while. And it was terrible, because then what happens if you need to exchange a file between companies? And it really just gets to be a mess. And open source is a way for us to all collaborate and combine all of the amazing minds that work for all these companies on problems that we all need to solve, that we all need solutions for, and that makes everybody's lives better and easier if we can use the same solutions. So I do want to talk a little bit about ACES, the Academy Color Encoding System. And that's the same academy that hands out the Oscar statues, the same academy that is the Academy Software Foundation is behind the Academy Color Encoding System. It's an open source image management framework that helps you create a real digital negative for a given project. 1.0 was released in 2014, and before that they were working on it for 5-6 years. So it's been in the works for a long time, been used for a long time. It was developed by hundreds of the industry's top scientists, engineers, colorists, visual effects artists, you name it, all coming together under the Academy banner to create something that we could all use and work on. And it really enabled us to create this system of saying, okay, we can all design this the way we want it. We have tons and tons of inputs and we have lots and lots of outputs, and we need to be able to work on all of them the same way so that we don't have to redo everything for every project that's different every time. It just takes so much time, and we need it to be consistent and to be reliable and to trust the data that we're given. So what happens is you get all of your different cameras, your drones, your primary cameras, your CG renders, and you use an input transform to get them into ACES. And ACES has a couple different what we call color spaces attached to it. We're not going to get into exactly, the technical details of what that means, but it gets into ACES. You do all your work there. You do all of your VFX work and your grading and your motion graphics and all of these things. And at the end, when you're done, you've got all that work in there, and all you do is add what we call an output transform to get it to your different displays. And so then theoretically, all your work is done in this common space. You can go back to it, you can change it, you can send it to somebody else to use. And it makes everybody's life so much better. And the other thing about it that I like is because it's open source and all these people are working on it, we're always working on it. It's a work in progress. We're working on version 2.0 to come out soon with lots of major changes, but we also have a release coming out soon that I want to talk to you about with my last couple minutes. That is something I've had the pleasure of working on, a small project for ACES in the last year called gamut compression. And I'm just going to show you a couple of these images of like small subset of what we kind of tackle as little bits and pieces in our ACES releases. And you can look at the top row of these images and you can see on the pig's nose, it's got this crazy blown out white nose and these pink fringes, and the lights on the DJ are really weird and solid, and the spotlights look like crazy creepy eyeballs. These images are not correct. And this happens a lot now with the use of the more popularity of having LED lights on set in particular. It happens a ton. And the current ACES iteration was not really equipped to deal with artifacts like this that are caused by what we call out of gamut pixels. So a group of scientists and artists and users came together over the last year, and I got to lead this with my colleague Matthias Scharfenberg, who also works at Industrial Light and Magic. And we got to help everybody come together and come up with a solution for these. And we come up with an algorithm that you can apply per pixel that brings these out of gamut pixels back into gamut. And it's complicated and it's things, but it took us a year. It took us a year of research and development and testing and figuring out what we wanted to do. But the bottom row of images are a fix for these out of gamut pixels. And this algorithm is going to go out in a next ACES release in a month for people to use and hopefully be able to solve some of these really harsh artifacts that they're seeing on their image that they don't know what to do about. Here's a couple more examples of some of the stuff that we fix and that we're able to fix with this algorithm. And it's just one small example of the kind of work that we do as a whole industry using open source and color science to hopefully make everybody's lives easier. And I really, really like it. I love it a lot. So to summarize, if it's not clear, I'm really passionate about what I do. Every day, it's a real joy. So find what you're after, what you're interested in, and just go after it. And the other thing that I just want to say is, I've said a lot, is open source is open. If you're interested in this, if any of this seems fun to you or you want to learn more, join us in the ACES groups, the Open Color IO groups. You can join the meetings, join the chat boards, just listen in. You don't have to say anything, just start to learn. And with that, I am going to stop talking. Thanks, everybody.
Awesome. Thank you so much, Carol. That was a fantastic presentation. I really, really enjoyed it. So next up, I want to welcome Michael Dolan from Epic Games to the speaking floor. Michael Dolan is the Open Color IO Technical Steering Committee Chairperson and represents the project on the ASWF Technical Advisory Council. Michael is a lead pipeline developer at Epic Games, contributing to a variety of 2D, 3D, and infrastructure tools and workflows across Epic's global art pipeline. Before joining Epic, Michael was a color scientist and senior software engineer at Sony Pictures Imageworks, focused on SPI's color, compositing, matte painting, and texture pipelines. So with that, take it away, Michael.
Hey everyone, it's great to be here. Before I turn my camera on, I'm actually recorded a talk so that I could show you some moving pictures and stuff and be easier to switch between it. So I'm going to go ahead and share my screen and play a video of myself presenting to you. And okay, here we go. Hi, I'm Michael Dolan. I'm a lead pipeline developer at Epic Games. It's great to be here with you all. I'm going to talk a bit about my career and the role color science has played in that. So I started out as studying visual effects and motion graphics in school and started my career as an artist, working primarily as a compositor and 3D generalist. While I was doing that, I started learning Python on some of my free time at lunch, in the evenings and the weekends. I was really interested in it as a way to kind of optimize some of my compositing workflows and to start really building more robust tools for my team. And I also started learning C++ as a part of that. And eventually I transitioned into working in pipeline and tool development full-time at 3D Excite, where I was working at the time. And I worked on developing their compositing pipeline for a number of years. Following that, I had the opportunity to join Sony Pictures Imageworks in Vancouver, working on their compositing pipeline. And I also worked on their digital matte painting and texture paint pipelines as well. I eventually became the color scientist at Imageworks, where I led the color pipeline there and development of that and managed color on the films we were working on. Part of that role, Imageworks was the creator of Open Color IO, which is an open source color management library. And I started contributing to that project. And around that time, the Academy Software Foundation had started up, and I helped lead the OCIO transition from Imageworks to the ASWF, and it became the second adopted project. And I've been serving as the Technical Steering Committee Chair of Open Color IO since 2019. Following my time at Imageworks, I had the opportunity to join Epic Games to work on their art pipeline. The Epic Games art pipeline team is a group of developers who work to build cloud-centric pipeline frameworks and tools to help artists who are working in and around Unreal Engine. We support the production of Fortnite and various special projects like the UE5 demo that came out last year and many other projects. We get to work across the boundaries of traditional visual effects and video game pipelines and work to build technology to support all sorts of real-time content creation. Now, I'd like to give you a brief look into how color management works in a studio environment, specifically as it relates to Open Color IO. Now, color science is a really deep topic, and we'll really just be scratching the surface here. But you'll get a glimpse into some of the problems a color scientist solves when supporting an art team. So fundamentally, images are buckets of color data. Let's look at this image from the UE5 demo last year, which is a great example of use of value and color to create a really compelling world. If we take a closer look at this image, you can start to see here that there's pixels. Pixels are these little boxes that make up the image, and at a distance, you don't really see them, you just see an image, but when you really start to look at an image up close, you'll start to see those pixels. RGB images contain additive red, green, and blue channels. A display emits light for each primary color, which is mixed to produce a color image. Now, the RGB color channels themselves, each channel is an array of numbers. Each number encodes light intensity for a specific primary color. The numeric types and behavior of those numbers vary by image state, capture, display device, and the file format. Looking at this image as a whole, you can see that there is a huge amount of pixels, about 3.5 million pixels in all in this specific image, which if you break down those channels, it's almost 10.5 million numbers. That's a lot of numbers and shows you that image processing can be very computationally expensive. Now, I mentioned OpenColor.io is an open source library. It's written in C++ and has Python bindings, and it manages color and content creation tools. OCIO config files contain detailed instructions for transforming between different color spaces, which are typically defined by a color scientist in a context of a particular production or studio environment. Each color space tells OCIO how to transform between a specific image state and a reference space. Now, the reference space is typically linear in nature, which means that color values are directly proportional to scene luminance or light in the scene. And when you convert color spaces in OCIO, we use something called an OCIO processor. So a processor contains all the mathematical operations necessary to implement the to reference transform of the starting color space and then the from reference transform of the destination color space that can be run on a CPU or a GPU to perform math on pixels. So basically, it's using the reference space as an intermediate image state between this transformation. In this way, color spaces are extremely flexible, and we can define the meaning of a color space once, and then applications that use OCIO can give users a consistent experience without implementing their own color science. So taking these OCIO color spaces and putting them a bit into practice here, we have what we call a viewing pipeline. So we have an input image with an assigned color space, and then we have a display that we're targeting that also has a color space defined for that specific display and the way we want to view color on it. And so OCIO is going to build a viewing pipeline from a processor, which is going to convert from our input image's color space to our linear reference space, and then from our linear reference space to any of these display color spaces that have been selected given the particular display being viewed. Now, each of these images looks significantly different here, but on each of their intended display devices and in their intended viewing environments, they would look like the sRGB image on the left looks to you now if you're viewing this on an sRGB display, but with the additional color and value range that their technology supports beyond sRGB capabilities. So let's look at, for example, in a visual effects studio. So you have your artists who are working on monitors at their desks, and then you have editors working in an edit suite, working on the overall cut of the visual effects shots. And then you have your supervisors and director in a theater looking at final shots and trying to approve and guide the work of the artists. And so each of these have drastically different lighting conditions and display technology, but fundamentally, each of these contributors to a project need to be looking at the same image so that they can communicate with each other. And so even though these environments and displays are different, OCIO empowers these tools to give these images the correct appearance in all these displays. And this really comes with the knowledge of a color scientist who's implementing the correct transforms within OpenColor.io. In a studio, a color scientist has many roles. We design color transforms that are used by all departments of a production. That's one of the neat aspects of working in color science is you work across the entire production. So you're one of the first to work on a film or a project because you have to set up the color pipeline and you got to talk to the client about what their color workflows and pipeline is going to be and match that. And you're also one of the last to touch pixels, doing final color approval before you ship off final final shots or a final project. So a color scientist implements or manages OpenColor.io in production tools. And why I say implements or manages is, and sometimes color scientists might be also a software engineer, and they might actually be the one physically coding OpenColor.io into an application through Python or C++. And other times, they're working with a tool like Nuke or Maya, where their OpenColor IO is already implemented, but it's just a matter of working with the artists on how to use this correctly within this environment. And the idea with OCIO here is that, no matter what application you're in and what display you're in, you can see the correct image, and it's consistent across the applications. So color scientists design methods for display calibration and consult in general on display technology, what displays should be used in a movie theater within a studio, at an artist's desk in a dark environment, at an artist's desk in a light environment, at an editorial suite, all these different places. What type of high dynamic range display would you want to look at to review how, the color is going to change between these different mediums? There's a lot of critical problem solving by a color scientist. That's one of the main roles, I would say, at least in my experience, has been that you're a problem solver. And you're working across all disciplines, from textures to lighting and rendering to editing, compositing, just really everything. And oftentimes these tasks are under pressure, so it's a job that has some stress associated with it sometimes. It's like when I was working, like I sometimes would have to fly down to Los Angeles to look at an image in a theater that didn't look right and try to figure out why it didn't look right. We also work a lot with standards committees and open source projects like OpenColor IO and ACES, another Academy project, and to contribute to overall industry growth, which is really valuable. Sort of the meeting of the minds between these different groups, and developing improved workflows across the industry. So just some general tips for getting started. My first tip would be resourceful. You can learn a lot from the internet. So I would say for me personally, like I learned to code on the internet. I didn't go to school to be a software engineer or a color scientist. I learned a lot of what I learned from the internet and from talking to other people. Don't be intimidated by those with more experience than you. It's okay to ask questions and invite feedback. And, a lot of times people really love to talk about stuff they're passionate about. And so it's a great opportunity to get connected with mentors and to be able to learn from those who've been doing this for a long time. Work hard, show initiative. I think open source projects like OpenColor IO are a really great way to get started. There's small and big tasks that can be they can get involved in on an open source project. You could be fixing a bug in code, you could be improving documentation. Really, there's so many ways to get involved, and it's a great way to just really get connected with people who are working in the field, in studios and on many different projects, and just to start to be a part of the conversation. Math is very key to color science and really a lot of computer graphics. I know personally, that's an area where I feel like I always want to grow more, and I always want to learn more math. And advanced mathematics is a really valuable skill to have. And physics as well, which deals with light. So as much math and science as you can learn, it's going to benefit you. Python is a great language to learn. It's sort of one of the standard languages of the science community. And if you really enjoy programming, C++ can be really beneficial too. So you can dig deeper into, image processing tasks and things like that. And I would encourage you to learn about rendering and compositing and fields like that and textures, particularly if you're interested in working in visual effects. As a color scientist, since you work across these different disciplines, it's really important to know about each of them to some extent, because, from one day to the next, you might be supporting completely different teams. And it really helps to understand how they work and why they work, to be able to, help them problem solve. And I know that's one thing that's helped me personally is, I may not have a very deep background in color science, but when I was working as a color scientist, I had worked prior to that as an artist in some of these disciplines, as well as in a software engineer. I'd written tools for a lot of these different disciplines. And so I understood the craft in a deep way already, so that applying color science to it, felt more natural. And so the more you understand about the artists you're supporting and how they work, it's really beneficial. Thank you for your time and for listening. And again, it's great to be able to share with you all, and look forward to seeing where your paths take you. Thanks, everybody. This is back me actually in person again. It's great to have you all here.
Awesome. Thank you so much, Michael. That was a fantastic presentation. So glad to hear it. So as I mentioned, we are going to have a third person joining Carol and Michael for the Q&A at the tail end of this talk, and that is Karen Ruggles. She's an assistant professor of computer science at DeSales University. She was one of our speakers 2 presentations ago, so 2 webinars ago. So if you did not see her presentation, you should definitely go back and watch it. But I'm going to invite her to the stage now so that she can give you a very brief version of her talk, so that everyone has a better understanding of her before we get to the Q&A. Welcome, Karen.
Thanks, Rachel. I just wanted to say that, one of the big things that we highlight during this career series is to just go out and do it. I think one of the biggest questions that I have from a student or from someone who's just trying to get started is, well, where should I even start? Which programming language should I learn? Should I learn Maya or Blender first? And, what we see throughout these series is whatever you learn is going to help you in the next step. Not one of these speakers knew exactly where they would be today, but they had a journey there. And part of that is being able to learn and being able to grow through that learning. So I just wanted to give that little piece. I know we have a lot of questions, and I encourage you to put your question in the Q&A box down at the bottom so that we can take advantage of this time with these wonderful people who are giving up their time to speak with you and answer any questions that you have. So please use that box and let's get the Q&A started.
Awesome. Well, go ahead and everyone join us back up here, and we can start answering some great questions. There's an awful lot of excellent questions in the Q&A box, so I think this will be a good chat. The first thing I wanted to start with, I'm noticing that lots of people are asking about the math behind color science. In particular, what branches of math are most important, and what sorts of resources are out there that people can use to learn about the math that is behind color science.
Yeah, I mean, I think that kind of like Michael said in his presentation, no math is going to do you wrong. We use all math. I think, it ebbs and flows how much math I do, but understanding the fundamentals and being able to apply it when you need to, and being able to know whether something is right. Because a lot of the times, we're not, just doing math and solving equations all the time, but sometimes you have to double check something. Sometimes you need to know what's in the realm of correct. And those things often end up being linear algebra. I saw that mentioned in the chat as it ends up being a lot of linear algebra, a lot of matrices. That stuff is the most common. Calculus is also common. You're a lot of times, solving for curves and fits, and it ends up being some trig too. So those 3 are probably, I don't know, Michael, if you have any others that I'm missing, but
yeah, the only thing I would add is that this is something that actually surprised me when I got into color sciences. I had been writing software for 2D and 3D tools before that, but a lot of the same math you would use writing tools to work with 3-dimensional, like 3D models. It's a lot of the same concepts behind color science, because really a lot of manipulation of color is related to manipulating things in 3-dimensional space. Like if you've heard of a LUT or a lookup table, there's different types of lookup tables, but one of the most common is a 3D lookup table, which, and so deals with 3 dimensions. And one of the main ways you convert between different color primaries is, as Carol said, using, a matrix math and like linear algebra. And so it's pretty neat if you can really take a lot of color science concepts and visualize them in things like OpenGL, because they follow a lot of the same principles.
Awesome. We also have a lot of folks asking about good places to start in this career. If someone has an interest in color science, either from this presentation or from past experiences, what would be ways that they would start getting into the industry? What might be a really good first project for a CS student who might be interested in color science?
I think that what really helps me a lot and still helps me to this day is getting involved in a lot of the ongoing conversations that are happening in Open Color IO and ACES are the two big ones. And there's also the Python Color Science library that if you just want to mess around, there's also Open Image IO, another open source project. That if you just want to mess around with things and you're more like on the programming side and you want to program and see what you could do with color, that's one. I think another place is there's tons of great books out there, and we can look at some of the things we talked about with the diversity and inclusion is, you know, putting together some lists of resources and stuff that are a place to start. And I can certainly follow up on our Slack channel with a couple books that I still reference and read. Their textbooks, they're dense, you know. They're not a ton of fun, but there's lots of great stuff on ACES Central too. If you just want to learn about some concept, the ACES Primer is a great just white paper on what ACES does and why it is and why things has some color science principles in there of why it was designed the way that it is. So that's handy for applications of stuff. I think the last thing that I would say too is just start messing around with color tools in different software applications, and like Resolve is free, or you could get a student edition of Nuke, and they've all got tons of color tools in there, and both have, you know, color spaces like what Michael was talking about. Nuke has Open Color IO built in, so you can grab an image and see what happens when you put a color space transform on it and try and see what's going on and mess around with a lot of the tools, and then work your way backwards and try and figure out why what's happening is happening. And that's sort of the way that I learned. It was very non-traditional. It was a lot of, this is wrong, we have to fix it.
Yeah, Nuke is like, as someone who, like, I worked in compositing quite a bit, so Nuke was like I used it a lot in general, but it is really like a color scientist toolbox. And there's a non-commercial version that's free, and I think they have an indie version too. But it's really great. Like if you just want to play with like how color works, like you can drop down an expression node in Nuke and just start tinkering with expressions to mix color channels and see how they behave. And that's one area where I just like to play around. But yeah, and if you're a CS student wanting to just get involved and on the development side, you know, there's a lot of open source projects, and like Carol said, OCIO, of course, and Color Science, and ACES is open source too. But like in general, in open source, if you go into the issues page on, say, OCIO's GitHub page, you can look at the tag good first issue, which will help you find sort of like entry level. It's more just stuff to kind of get you familiar with the code. And the more you start to contribute in just little ways, you'll start to get familiar. And it's cool because you get a lot of feedback from the people who have been working on the project for a long time. And that is just, it's really great mentorship opportunity in general.
Yeah, and coming from the traditional side of education, you can also involve faculty members. So if you're in that junior or senior level, you can speak to your faculty mentor or a computer science professor about taking a independent study with that faculty member to create that partnership, create that structure around learning where they can also help you. There's obviously a lot of support within, GitHub and just the regular, just open source community that you can definitely leverage to help you if your faculty member is not so great in that space. But you could also do that at the club level. I think part of the continuation is just keeping everybody together. So if you just grab a group of friends, whether that's in the club or, just as a Friday night, that's what you guys are doing. The point is to just keep moving that forward and dedicating that time continuously. And as you start to do that, you'll see that you improve and you have more of an intuition for it rather than asking questions.
And I just dropped a whole bunch of links in the chat. I'll drop those two in our students channel and our diversity stuff in the ASWF Slack. So don't worry if you forget any of them, we'll make sure they're available to you. Two, I want to point out, three we've talked about, but the top one, cinematic color, is is just a great like reference handbook for why we do color the way we do. It was developed by the Visual Effects Society. If you just want to learn in general about a lot of the topics we've been talking about, and it also has got some great links in it to get you deeper into some topics if you're curious. And then the last link that I sent is a YouTube video that was just released yesterday by the Foundry. That is an hour-long color management fundamentals and ACES workflow, and it's part 1 of a 4-part series that we're working on with the Foundry to explain some of these topics and hopefully make some sense out of them, because we know that information on this stuff can be hard to come by. So
awesome. We've had a lot of technical questions too. One of the things that you guys have mentioned multiple times is ACES, which is obviously very important to color science in our industry. And we had one folk who asked, what's one of the technical challenges that arose during the development of ACES? Or maybe another way to look at it, what is one of the big things that ACES solved for the industry? Yeah, what do you guys think?
Yeah, I mean, ACES solved a couple different things. I think that, we could talk about, there's a couple things that we're working on for ACES 2.0 that, it's hard not to get into the weeds of like exactly what we're trying to solve with ACES 2.0, but really what helped, the big thing about ACES is accessibility, right? Before ACES was released open source, you had to have a color scientist at whatever studio you were working at or whatever DI house you were at in order to deal with any camera coming from set and how to get that into a state where it was finished correctly. And there was no way for an indie filmmaker to easily have correct color science on their film. And what ACES did was take a lot of the knowledge that we developed in these high-end houses over a lot of years and open source it in a way that was a standardized framework with documentation, so that if you want to use it, and then software started to adopt it. And so you could have your same color management framework in multiple different softwares, and OpenColor.io plays a big part of that because it's a big vehicle in order to enable ACES. So they all kind of play together, but the gamut mapping is one too, of like, you think of like a problem that we had to solve that like was in beginning of ACES and now we're trying to fix. There's lots of different things like that, I think, and we're nowhere near done. So
yeah, I know when I was working at Sony as a color scientist, we switched to ACES. So that was like one of the initiatives I helped work on when I was there, adopting ACES in the studio. And one of the great things about it was that prior to ACES, we would potentially have different final looks for some movies we worked on. And when you get to the end of working on a movie, particularly for, I guess I'm specifically talking about animated movies here, there's a step where you have to basically take your final pixels and take it to a DI house where they'll do the final color grade for the theatrical release and home release and stuff. But when you're working in a visual effects studio, you're working on these linear images. And so we're handing off these images that don't have the final color applied. And then we're also handing the DI house, which is digital intermediate, that's what DI stands for. We're also giving them lookup tables. And then the hope is that what they're seeing in their suite matches what we saw at our studio. But oftentimes, I was living in Vancouver, so like usually towards the end of a movie, I'd fly down to Los Angeles and go into the theater and look at it, with everybody and make sure it's looking good. But when we switched over to ACES, we could just say, hey, we're using this output transform with ACES, and you could just literally give them a link to the file in GitHub and say, this is the transform, and then they just apply it on their end, and we know we're looking at the same thing, and it saves some trips. And then it's also really nice because it's having standards, at least in visual effects, studios work together a lot, and so having any sort of standards you can have is really amazing.
Awesome. In a similar vein, talking about problems that have been solved, we have another question. What's the most interesting or challenging problem you have solved as a color scientist, and how did you solve it?
I can say that for me personally, and I can't say that I succeeded in fully solving this problem, but one of the most interesting problems I got to work on was when we started working more on high dynamic range content, and the problem with high dynamic range is that you have to have a special display to see it. And so the problem is when you have artists working on standard dynamic range, which means they're not as bright as the displays for high dynamic range, how can they, creatively work on these images to look cool in HDR displays without having an HDR display at their desk? And so there was a lot of experimentation around ways to simulate or be able to look at like pixels that are brighter than what their screen can display. And I don't know, I think that challenge is still there, but it was a fun one to work on.
Yeah, that's a huge problem and something that I want to hear more about, Michael. Everybody has those questions. But I think for me, I mean, and the hope is that there's always something new and some new challenge that you hope tops the last thing that you've done. And that's happened a couple times for me. But the project that I mentioned is really the one, and I can't say that I did it myself. It was not. It was a group of 30 people from all over the industry, and that's the other thing that I think is like it's not problems that I sit and solve in a corner. A lot of our job is working together to figure out the solution, and so yeah, ACES that ACES group that I led though was really rewarding, and was a tough challenge to solve, and hopefully we've solved it well enough. It hasn't been used enough to say, so we'll also come back and ask me in 6 months.
Awesome. So I have one more question for the two of you before we wrap it up. So how did you come to the conclusion that color science was the perfect fit for you? Was there a moment, or was there a project or something that you did that really stuck out to you?
I have a funny story on that one, and it is kind of hilarious. Rachel will know the person I'm going to mention in this story, but I didn't know that color science was a thing until I started working at ILM. It wasn't a stuff, and I was working on some scripts and things like that. And at the time, I thought I wanted to be a compositor, and so I was working on some scripts for a project that I was crew to that had to do tangentially ended up with the color pipeline. And I'm just like this la-di-da newbie that's like editing scripts and doing these things. And I, committed to our Perforce repository. And then a couple minutes later, I get a phone call from our color scientist at the time. His name was, I'm just going to say his name because he knows this. He's from Robert Mulholm. And he was like, "Why are you changing my code?" And I was like, "Oh, it was broken. I needed to fix the thing for the show." And he was like, "It was broken on purpose." And I was like, "Okay, why?" And he proceeded to show me through the steps of like all the things, like why he left that one part broken so that these 6 other things didn't break until he had the time to fix this one thing. And it was fascinating and crazy. And at the end of it, like at the end of the phone call, I was like, "Could you teach me more about this? I'm fascinated. I don't understand any of this, and I don't want to break your stuff again." And he was like, "Well, yeah, I guess if you really want to learn." And then he became my mentor, and he taught me stuff. And it took a couple years, but then that was how I became a color scientist. So.
Yeah, and for me, similarly, I didn't really know much about color science until I was already working in visual effects. And I was a software engineer working on compositing, and naturally working compositing, I had to deal a lot with color science. And so, but I worked with our color scientists at ImageWorks a lot. We collaborated a lot, and we still talk to each other. And so at some point I had the opportunity to kind of to transition into that role. But yeah, I think it was the same, just kind of, seeing the problems and learning from those around me who were already trying to solve them. And I think the thing that I thought was most interesting about it was that it's a really nice blend from, at least from a software engineer perspective, it's a nice blend of, you know, programming problems and artistic problems. They kind of both fit together. And so I found that pretty fascinating.
Awesome. Well, thank you so much for this fascinating Q&A, Carol, Michael, and Karen. Now, before I let everyone go who's watching this presentation, I just want to share a couple of additional slides. Let's see if I can find the right tab. So as everyone knows, this webinar series is a part of the Academy Software Foundation, and the Academy Software Foundation is an open source organization, which means that everything is open. We've mentioned this in all of the webinars. We really recommend and encourage anyone who wants to participate with the Academy Software Foundation to do so. We have a Slack instance for the Academy Software Foundation that you can join. We have mailing lists that you can join, but in particular, we have one specific new channel in our Slack instance called Students that we really would love for you to get involved with and be a part of. So go ahead and join us on Slack and ask all the other questions that you might have in mind. I also want to remind everyone that we have another one of these presentations in 2 weeks on April 15th. This one will be on, like I mentioned, VFX careers pipeline developers. We have Kirk Chantrain from ILM speaking, along with Alexa from Shotgun. So yeah, definitely join us for that presentation. It's going to be pretty fascinating as well. And with that, I just want to thank everyone for coming, especially our speakers who have shared so many amazing stories with everyone. So thank you so much, and hoping you join us again in 2 weeks.
Bye, everybody.
Bye, everyone.
Bye.